Okay, so we're doing linear inequality application. A couple things that we are going to talk about is keywords per inequality. So my first inequality we're going to talk about is this one. What inequality is that? Greater than or equal to. Okay, another word for greater than or equal to is at least. If I say I have at least $6, I can have $6 or more. So that's why it's greater than or equal to. Also, another one is no less than. Sometimes the extra words confuse y'all, but if y'all think about it with money, it usually helps. Okay, less than or equal to. Another word you can use is at most. If you have at most $6, then 6 is your biggest. You can only have less than that. Okay, no more than. And what if I say budget? Why does that fall here? Yeah. If you have a budget of $6, you can spend $6. Can you spend more than 6? No, but are you okay if you spend less than that? Yeah, and that's why this works there. Now the last two, we're not really going to put a bunch of words for those. This is just less than, which hopefully you know. And this is greater than. Okay, so we are gonna do number 1. So number 1 says 12 subtracted. So 12 subtracted from is a keyword here, and we're gonna talk about it in just a second. 3 times a number that we don't know. And then it says is less than, so less than 21. Now, going back, when you see the word from, it means you're gonna write it backwards. So what's coming first? 3x minus 12. So I can't take $12 from you if you don't have money to begin with. So you have to have something before you can take something from it. Okay, so then how would I solve this? Yeah, add 12 to both sides. I get 3x is less than, you're exactly right, 33. Now what?
Divide by 3.
Divide by 3, and I get x is less than 11. Now, it says find all the numbers that make this statement true, therefore we are going to put it on the number line. Not all of them today will you put on the number line. So we have 11, and it says x is less is to the left. Is it equal to? No, so we're going to close parentheses, or just a parentheses, and then there's my sign. So it goes to the left forever, so negative infinity to 11 with a parentheses, and infinity always gets a parentheses. Any questions with that one? Okay, so let's look at the next one. Now we're actually not going to go all the way through the next one because it's the same thing. We're just going to talk about setting it up. So it says twice a number, so 2x subtracted from, which means I'm going to rewrite this backwards, 35 is greater than 15. So what is this left side going to look like? Nope. 35 minus 2x is greater than 15. Because when we see that word from, we have to have something in front of it. So we're not going to solve this one because it's the same thing, so we're just going to keep going. Okay, look at example 3. It says Maria Chase and Jonathan Edwards are having their wedding reception at the Gallery Reception Hall. They may spend at most $2,000. So what symbol am I going to use? Less than or equal to $2,000. Okay. If the reception hall charges a $100 cleanup fee plus $36 per person, okay, well, $100 no matter what. If I have one person, if I have a billion people, I'm going to pay that $100 cleaning fee. It even tells me plus $36 per person. Do we know how many people are coming? 36. Yeah, so we're going to use our X. Anytime you see each, every, and per, that tells you where a variable is going to go. Okay, how do I solve it? Minus 100 on both sides. Get 36x is less than or equal to 1900. Now what? Divide. And what do I get? X is less than 52.7 repeating, right? So here's my question. Can you have 52.7 people invited to your wedding? No. Okay, so then it tells you find the greatest number of people that they can invite. Can they invite 53? No. Can they invite 52? Yes. So it's 52 people or less. Because can they invite less than that? Yes. So we're not going to do a bar, a number line, because when you shade like this on a number line, I want you to realize you're saying that we can do 10.9, 10.8, 10.76543, whatever, a billion decimals. Can you have a decimal amount of people? That's why the number lines don't make sense on a lot of word problems, because you can't have but whole numbers when it comes to people. Okay, one more. It says Kasanga is eager to begin his education at his local community college. He has budgeted $1,500. What does budgeted tell me? What symbol? Less than or equal to. So yeah, he can spend $1,500. Can he spend more? No. That's my max amount. His local college charges a $300 matriculation fee and costs an average of $375 for tuition fees and books for each 3-credit course. Okay, in college, some of y'all are going sooner than others. I think some of y'all are juniors. I meant that as in juniors versus seniors. A 3-hour course is like a regular one class. They call them like by how many hours you spend in that class a week. So this is just one class. So don't let that throw you off like we have to plug in the 3 somewhere. Okay? So how am I going to write that piece? Well, what was the fee I'm paying no matter how many classes I'm taking? $300 plus what am I paying per or each class? $375x. How do I solve that? And 375x is less than or equal to 1200. Now what?
Divide by 375.
And I get x is less than or equal to what? 3.2. Can you take 3.2 classes? No. So what's the most amount of classes they can take?
3.
So we can take 3 classes. Can we take less than 3?
Yes. Oh, yes.
We cannot take more. Any questions with that? Okay, that's your notes. One thing though, I do want to go over a couple things on the practice. There's a whole 5 problems, meaning I left plenty of time to finish yesterday and the day before's practice. I know how much I love word problems, that I felt like I overloaded y'all with them last packet, so I was being nice. Number 2. Ben Holiday bold 146. We'll freeze first on number 1. This is 6 more than twice a number. When I say more than like that, I didn't say 6 is more than, or I did, I guess. But 6 more than, what does that mean? Add, subtract, multiply, or divide? Add. We're not looking for a like symbol there. Yes? Okay. Okay, on number 2. So Ben Holiday bowled 146 and 201 in his first 2 games. He must, what must he bowl? So what we don't know in his 3rd game to have an average of at least 180. What symbol am I using for at least? Greater than or equal to. Okay. And how do you find average? add and divide by, well, there's 2 given, but we're talking about a third one also. So if we have 146 plus the 201 game plus, do we know what he's going to score on the third, or is that what we're trying to find? So if I'm adding 3, how do I find the average? What am I going to divide by? 3. Now here's my question. How do we get rid of division? Okay, one thing I've seen a lot of today is people actually trying to distribute this 3 in. Don't do that. That makes your life hard. Doesn't multiplication cancel division? Yeah. So these should just cancel each other. Now you will have to actually multiply that side. But don't cancel and multiply, because then you defeated the whole purpose. Okay? You technically multiplied by 9 if you do both. Okay, look at number 4. We have a 150-pound person uses 5.8 calories per minute when walking at a speed of 4 miles per hour. How long must a person walk at this speed to use this many calories? This is an extra number. This is an extra number. Don't let those throw you off. Okay? Lastly, what does twice a number increased by 1 look like? 2x plus 1 is in between -5 and 7. So I know it's in between -5 and 7. As long as I write at least to greatest, you'll always use less than when it tells you in between. Do we know how to solve these problems? Yes. So we've done those problems before. Okay, so this is your practice.